It's day 2 in geometry, and it is Tuesday, October 7th. And for your do now, you should have solved for the specified angle or angles using the angle addition postulate. And again, can anybody remind me what the angle addition postulate is? What is that? A plus B equals C. As long as A and B share a side length, I don't know if that's what you would call it, not a side length. If they're sharing a ray and a vertex, meaning they are adjacent, right next to each other, you can add them together to find the combined size of the full angle C. So it's just a rule that we follow. So for number 1, I drew you a picture. And you are supposed to find angle B. I gave you angle A. I gave you a value for angle B. That's 2x minus 4. And then angle C is 74. Now, I yesterday didn't give you anything like this. I gave you something similar where maybe it was B equals X or B equals X plus something, X minus something. But I threw a 2 in front of that X just to see how we could handle it. I want to see how well we did. So looking at number 1, does anybody have an idea of a good equation we could write to begin this problem? Yes, Jessica.
28 plus 2x minus 4 equals 7.
Mm-hmm. We're going to do 28, that's A, plus B, 2x minus 4, equals C, 74. So there's our equation. It's written. What would I do next?
You combine your 28 and your 4.
Yeah, we want to see if there's any like terms to combine, and there are. I have 28 and I have minus 4. So I want to also mention, yes, you can start by combining like terms. You can also, if you don't combine, you could add 4 to both sides. You could subtract 28 from both sides in whichever order you prefer. That will give you the same answer. So if you didn't combine like terms, that doesn't mean you're wrong. You just did it a different way. So what is 28 minus 4?
24.
24. So I'm going to bring down 24. What else comes down?
Your 2x plus 2x equals
Plus
74.
2x, good, equals 74.
Then you're going to subtract 24 on each side.
Yeah, you will do that. Now, is it okay if I put 2x plus 24 equals 74? Yeah, that's okay. You can absolutely put them in either order. You'll still have the same answer. And then you said we'll subtract 24. We're trying to get x by itself. So let's do that. Minus 24 from both sides. And something I've been doing in my Algebra 2 class, I have a student that really likes to do equations this way that might help you guys too. It's really easy to lose track of what is on which side and all those things. To keep yourself organized, drawing a line through your equal sign can really, really, really help. Because then you know you're not going to move that equal sign on accident. You're not going to put numbers on the wrong side. You're just bringing things straight down, keeping them organized and in line. I thought so too. I've been trying to do that with my problems, and I feel like it's helping. Everybody's like catching on a little more quickly just with that line. Okay, so my 24s cancel. What comes down?
Your 2x
2x
equals 50.
equals 74 minus 24 is 50.
Then you're going to divide by 2 on each side.
Divide by 2. 2's cancel.
Your x equals 25.
Perfect. X equals 25. Okay. Am I done? Have I solved for B?
No, you got to plug in x.
Yes. So this is the next step. Once I know what x is, I can use that to help me find angle B, because angle B is written right now in terms of x. There's an x still there. I'm going to replace the x with that value we just found, with 25. So down here,
2 times 25.
yeah, angle B equals 2 times, instead of x, 2 times 25
Minus 4.
minus 4.
And 2 times 25 is. So all that together will equal 46 degrees.
It will. 2 times 25 first, that's 50, minus 4, and 50 minus 4 is 46 degrees. So angle B equals 46 degrees. Now, I know I threw a little bit of extra stuff in there as a challenge for you guys. How did you guys do on that one?
I did okay once I got.
Yes. Does anybody feel brave to maybe tell me any wrong answer you may have gotten and the mistake you made? Yes.
I got 13 for X.
You got 13 for X? Okay, so let's go back to the beginning. Is this what your starting equation was?
Yes.
28 plus 2x minus 4 equals 74. Okay, what did you do next?
Find the like term.
Okay, so did you do 28 minus 4?
I did, yeah.
Okay, did you get 24?
Yeah, I did, but I put the 2x in front of it.
Okay, so you had, let me get a separate little sticky note so I can write your work out. You had 2x plus 24, is that right? Equals 74. Okay, and what'd you do from here?
Divided the 2. I thought you were supposed to do that. That's why
I see. Okay, so you divided by 2 here. So under the 2x and where else? The 74?
yeah, so.
Okay, so I see why you're wanting to do that, because you're probably thinking, okay, well, let's get x by itself. Now, technically, you could divide by 2 at this step, but if you divide one thing or two things in the equation by something, you have to divide everything. So if I divide by 2 here, and I divide by 2 here, where else do I also need to divide by 2? 24. That's honestly why we usually try to get rid of addition and subtraction first, just so that you don't have to divide more than 2 things. But technically you can do this. You can do this as long as you're doing it to everything. We're dividing the whole equation by 2. So let's see if this would work. Let's see if we get the right answer here. Divide by 2. That gives me x. What's 24 divided by 2? 12 equals, what's 74 divided by 2? 57?
37.
Oh, sorry. 37. Okay, and then what would my last step be?
Subtract 12.
Yeah, subtract 12.
And it's 25.
And you still get 25. That's so weird. It works. I know I've taught you from the very beginning, if you've been with me from pre-algebra,
Yes.
always get rid of addition and subtraction first.
Yep.
There's a reason for that. The reason is sometimes we get decimals if we divide first. Now that we're up in this upper level, my goodness, you can bend things a little. You can divide everything by 2 if you want to do that. But if we want to be safe and not accidentally make the mistake of forgetting to divide the 24 also, because we're not used to that, I would recommend doing minus 24 first, for sure. So I know I went off of what you were telling me, Milena, a little bit. So it looks like you divided by 2 there, divide by 2 there, but did you not divide 24 by 2? Is that what happened? Okay, gotcha. And so I'll finish off what you had done. I bet you came up with x plus 24 equals 37. Is that what you started with here? Okay, then you subtracted 24. And you got x equals 13?
Yeah.
Okay. Does it make sense why that doesn't work? Perfect. Okay. Is there any other brave people that maybe made a different mistake that you'd be willing to share that may help someone else in here? I think this is where you get the most learning done, is looking at mistakes.
I said the equation of this thing, but I subtracted 28 from 74 first.
Okay, so let me do that. You had the same equation, 28 plus 2x minus 4, right? Equals 74. And you said you subtracted 28 first? Okay, so let's do that. Let's see. Minus 28, minus 28. 28's cancel. What did you bring down at the next step? Mm-hmm. 2x minus 4 equals 46. Then what'd you do? Add 4. So far, this is actually correct. What'd you bring down here after you added 4? 2x equals 27?
No, I'm sorry, I wrote all.
Oh, you're okay, you're okay. But you did bring down, I'll write the 2x equals, and then what did you put under the 46 plus 4? 50. Okay, that's right. You divide by 2. And then what'd you get? Okay, so guess what? It's not a mistake. You did it right. You just did it in a different way. So that's another thing I love about the upper level is there's so many more ways that you can solve these equations and you'll still get the right answer. As long as you're following the rules of math, you can do it in a million different ways.
3 different equations.
Well, you got the right answer. Awesome. Okay. Good. Good discussion. Okay, do we have any other questions, things we want to share, comments? Or would we like to move to number 2? All right, let's go ahead and look at number 2. Another curveball. I was just feeling sneaky today, I guess. I don't know. Okay, so for number 2, it says find angle D and angle E. Ooh. Okay, so angle D, I don't give you a measure. Angle E is x plus 5. Angle F, 112 degrees, meaning that whole thing. Now, it's not ABC like the last one, but the relationship is still the same. The two smaller angles, add them together, equal the bigger angle. Who has an idea of how we can start this?
So D the square.
D is the square. What does that mean?
So that would be the right equal.
Okay, so D is a right angle. What does that mean?
It's exactly 9.
It's 90 degrees. You're going to see this a lot with angles. If you ever see the little red square instead of an arc, that's a 90-degree angle. That is a rule. It will never, ever, ever change. So right off the bat, you have to recognize this is 90 degrees. That should be in your notes from yesterday, but if not, make note of it today because we'll see this often. D is 90 degrees. So now that I know angle D, can I do something else?
We can make the problem.
We can make the problem. Let's write an equation.
90 plus x plus 5 equals 112.
Yes, 90 plus x plus 5 equals 112.
If you combine your like terms with this 95 and that'd be 95.
Yes. Okay, so here's our equation. 90 plus x plus 5 equals 112. We'll go to the next step where we combine like terms, 90 and 5. And that is 95. I'm going to bring down x first this time. X plus 95 equals 112.
You just 95 from each side.
Yeah, that's what we do. Subtract 95.
Your x is going to equal 17.
Okay. All right, so I'll bring down my x equals 112 minus 95. You said 17. Okay. All right, so we'll stop there for a minute. Make sure everybody sees what happened. Do you have any questions before we go forward? So, somebody else, I'd love for someone to raise their hand, someone that maybe hasn't spoken yet today. I want to hear some of your voices. Now that we know what x is, how can I use this to help me solve for the other angle I need, angle E? Kelsey.
And plug your 17 into x plus 5.
Yes, I know that angle E is x plus 5. I know that x is 17. So we're going to plug that in and replace the x. So I'm going to write angle E equals, instead of x plus 5, 17 plus 5. And what is 17 plus 5? 22. So angle E is 22 degrees. Very nice, guys. Did you get that?
Yeah, I did that one.
Good.
That's what I was like, I was looking at
Nice.
Yep. Did it.
Nice. I love it. Okay. Does anybody have either a mistake that they made and realized why, or a different method maybe you used to solve this problem, or questions? Everybody feel okay about number 2? Okay. All right. If so, let's look at number 3. Number 3 is interesting. I didn't tell you the measure of any angles. What on earth? Okay, number 3, I have these angles labeled X, Y, and Z. I want you to find all 3 of them just by looking at it. Is this possible to do?
Yeah.
It is. It is.
Absolutely.
Okay. So what are you thinking?
X 90 degrees.
How do you know?
Y 90 degrees because they're square.
Yeah.
X is not 90. Y is the 90.
Y is 90, but guess what? X is also 90. How?
There's no square.
There is no square, but it's because we didn't know that it needed a square yet. Let's talk about this. Let's walk through it. I'm going to zoom in a little closer. If we go back to our notes from yesterday, I'm going to pull out, let's see, the types of angle chart.
I'm looking at.
I know that if there's a square, it's 90 degrees. So I know that. I also know that a straight line or a straight angle like this is 180 degrees. So there's my 2 angles that are going to help me. Let's use this information to fill in that picture. So I'm going to start with, I see a box, I see a square. This is 90 degrees. Angle Y is 90. It's not supposed to be 98. It's my degrees. Okay, 90 degrees for Y. I don't know X yet, but do I know Z? Yes, Z is that straight angle. It's 180 degrees. So I know whatever Y is, or sorry, whatever X is, if I add it to Y, it will equal 180. So let's write an equation. X plus Y equals Z. I know Y is 90, so let's do X plus 90 equals 180. Do we see how that equation came about? Do we see where that came from? Okay. Yeah, subtract 90. And X equals also 90. Look at that. Done. Sometimes the ones that look the strangest end up being the shortest, easiest problems, as long as you know the information and you got your notes on you to look back and figure out those angle measures. 90 plus 90 is 180. So X is 90, Y is 90, Z is 180. And that was number 3. Okay. Any questions? Nope, you don't have to turn this in. This is just our kind of practice together activity, reviewing yesterday and, doing a little extra practice playing around with it. So you don't need to turn it in. You get credit for being here. Does anybody need to see any of this, or can we move forward? Okay. Bless you. All right, we're going to start a page of notes because kind of like what we saw in number 3, there are some angle relationships that we need to be able to recognize just by looking at them. So we're going to learn about some of those relationships today. I'm going to title my page, this is day 2. So I'm going to write day 2 notes. And I almost wrote algebra 2, geometry. Unit 1. Page 1. And I'll put the date over here, Tuesday, October 7th. So we're going to talk specifically about 90-degree angles, 180-degree angles, and we're going to go up one more level to a 360-degree angle. So let's talk about it. Let me first title this as angle relationships. So this is more kind of expanding on yesterday and a little bit of vocab mixed in. So we're going to start with a little bit of a rough sketch. It does not have to be perfect, although, I always say that and then I regret not using a ruler. I'm going to use a ruler or a straight edge. Actually going to use my protractor because it's shorter, so it's a little easier for me to hold up. We're going to draw a 90-degree angle. So we need one ray shooting straight up, one ray going straight to the right. And I'm not going to make it too big. I'm going to make it like 3 spaces tall here. So let's do, well, I made it 4 spaces. That's all right. One ray going straight up. One going straight to the side. And we're going to put a ray coming out of the middle. It does not have to be perfect. It can be a little smaller, a little bigger, doesn't matter. And inside of this right angle we've drawn, we're going to put a big red square, a box like that. And beside that, I am going to write what this relationship is called. These 2 angles, without even naming them, what would these 2 angles add up to? 90 degrees. We know that because of the red box here. Anytime we have angles that add up to 90 degrees, we call those complementary angles. Complementary. Complementary angles. And that's just angles that add up to 90 degrees. Now, it doesn't have to just be 2 angles. If I drew another ray in here, I would have 3 angles. Those are still complementary. I would just need to add all 3 of them up to get the 90. So the next relationship we'll talk about, we're going to draw a straight line. And a ray coming out of it somewhere, anywhere you like. And what would these 2 angles add up to? 180. So whenever I have multiple angles that when I add them together, they form a straight line, they are what is known as supplementary angles. So I'm going to write that word next. Okay. See if this is dark enough. Yeah. Supplementary angles. Supplementary. Supplementary angles. And the way I always remembered the difference between the names, complementary makes a corner. Complementary. Corner. Complementary. Corner. Supplementary. Straight line. Just the sounds. I think it helps. So supplementary angles are angles that add up to 180 degrees. They make like a half circle, a semicircle. Now, the third relationship we'll talk about, instead of starting with a ray or an actual angle or a line or anything like that, we're going to start with a single point. And really, I should make the points or the vertices more pronounced on those. So here's a point. From that point, I'm going to draw, I don't know, maybe 3 random rays coming out of it. So I'll put one shooting straight up. I'll put another one over here. And maybe another one. Don't accidentally make a 180-degree angle. Do like that, maybe. For this third angle relationship, my arc is going to go all the way around because here is an angle. Here's another angle. Here's a third angle. Now they're not all equal, but I am just circling this like that, all the arcs connecting. These don't have a fancy name like the first two. We just call them angles around a point. So angles around a point. Angles around a point are angles that add up to a full circle, a full 360 degrees. Because 180 degrees is half of a circle. If I add half of a circle to another half of a circle, I'm just doing 180 plus 180, and that's 360. So these are angles that add up to 360 degrees. So it's important to know that sometimes you are not going to be given the measure for all the angles together, bless you. Sometimes we may need to just know that if these angles are sharing one of those boxes, one of those squares, they're going to add up to 90. If the angles are on a straight line, they're supplementary. They're going to add up to 180. If they're around a point like this and they're making a full circle, they're going to add up to 360 degrees. So make sure that you've got this written down somewhere because it will come in handy. Will certainly come in handy. Now, once we've got that all written down, I want to talk about a couple other things that can happen with angles and lines. So I'm just going to scoot that up a little bit. And if you have enough space on your paper still, just put it on the same page. If not, it's okay if you need to go to the next page. It's all relevant. What I'm going to do here is I'm going to draw a, let's see, I'm going to draw a straight line going across, and I'm going to make it about 4 inches. And I'm going to put arrows on the ends of my line. And directly below the first line I draw, I'm going to skip at least 2 spaces. I think I'll skip 2.5. But I want to draw a second line underneath this line going at the exact same angle. So don't make one line straight, one line tilted. We want them to be going at the exact same angle. So I'm going to get it as close as I can. Line it up. It doesn't have to be the same length, but it does need to be going at the same angle. I'm going to draw my second line. Just like that. And on the ends, either near the beginning of the lines or near the ends, I'm going to draw a little, look like a play button, like a triangle that I'll fill in red on both of those lines. Does anybody know what those little triangles are put there for? What does this mean? Yeah.
Okay. Is that kind of like, the square box or whatever, like a
Very similar.
very similar?
Very similar. It's a label that tells us something about how the lines are related. So it's not giving us a measure, but it is an indicator of something.
Which one is going?
Which way it's going? Actually, kind of yes. Kind of yes. Which way it's going? So what I'm going to tell you is, since these triangles are the same on these lines, it's telling us that these lines are going in the same direction, exactly the same direction. These lines are what we call parallel. Anybody ever heard that word, parallel? I bet you have. Parallel parking. Yeah. Parallel. Parallel. These are parallel lines. So they are like exact copies of each other. They're going at the exact same angle. So what I'm going to do over to the side somewhere is write, kind of pointing at both of these lines, parallel lines. Parallel, parallel lines. It just means they are going at the same angle. Going at the same angle. Meaning, if I were to continue these lines in both directions forever and ever and ever and ever off to infinity, will these lines ever touch each other? No, never. They will never, ever touch, ever. They're always going to be this exact distance away from each other. So if I know that these lines are going at the same angle, what if I drew a third line crossing through both of those lines? Let's do that. I'm going to draw a third line that just passes through both of those lines. We've made some angles, haven't we? Suddenly there are 8 angles on my page with just 3 lines. I've made 8 angles. What are those angles? Let's take a look. I have an angle here, there, here, there, here, there. I'm going to label them as A, B, C, D, and let's just look at A, B, C, D first. And I'm going to pass something out to you guys while you finish copying that down. That's going to help us to see this relationship. Pause. So everybody should have a lamination sheet, which is tough to see on camera unless it's reflecting, and a dry erase marker. So here's what I'm going to do. I'm going to take this lamination paper and I'm going to put it over the top of my parallel lines. Now I'm going to use my marker and I'm going to trace, let's trace angle A. Like this. So I traced angle A and I'm going to label it as angle A. So now I can move angle A around. And cool. So I've traced that. Now I want us to take this little sheet that I've given you and kind of play with how you can move angle A around and see, are there any angles that are equal to angle A whenever you move it around and line it up with other angles? Tell me if you find one that's equal. And just shout it out if you figure one out. Angle C is equal to angle A. So here's my angle A. I'm going to line it up with C. Oh, which one? So here's C. Go straight down.
No. No.
Wait a minute. Wait a minute.
Yeah, right there. Yeah.
Ah, okay, so I just don't have a label for that. How about this? A, B, C, D. We'll call this E, F, G, and H. Okay. So now we can look at it. So angle A, now tell me again, what is the angle name that this is equal to? Instead of C, we have a new label for it. What is it?
E.
E. Oh my gosh, what on earth? A and E are equal to each other. How can that be? Well, does it make sense that if parallel lines go at the same angle, if a line that is just one line, it's the same line, go through the same angle twice, don't you think they would make the same angle? It's like a copy of itself right below. So angle A and angle E are equal. Angle D. Oh, it matches angle D. What else? H. Oh my goodness. Okay, so here's what I would love for us to do. We see that they are the same. Let's mark them by putting the same number of arcs. So angle A, I'll start with one arc. And we said angle A is equal to angle E. So one arc on angle E. We also said angle D and angle H are equal. So we'll put one arc on both of those as well. Okay. So what if I look at angle B now? I'm going to trace angle B. What angle is equal to angle B? C is equal. When I flip it around, sure enough, it lines up real nice. Any other angles? F. So here's angle B. Move it down. Oh, it lines up with F. What else? G. If I flip it around, it does line up with G. Okay, so let's mark those. Now, I've already used one arc, so for these, we want to use a different number of arcs. I'll do 2 arcs. Now we have this nice little pattern. So I know A, D, E, and H are equal. I know B, C, F, G are equal. Kind of cool. So we can use this information to help us solve for all sorts of stuff. Looking a little bit closer at this, I wonder, do we recognize any of these 3 relationships in these 8 angles? Do we see any supplementary angles, any angles around a point, any complementary angles? Supplementary? I think you're right. So a good way to check, if you're wanting to use this little clear thing again, what if I trace straight line and just see how many straight lines I can find? I'm just going to do this. Bless you. Okay, that didn't work out as great as I thought it would, but okay. Let's see. What angles can I find that line up with this straight line? A and B. Those are supplementary. They should add up to 180, right? Here, I can do this too. A and B add up to 180. What other 2 angles could I add to 180? E and F, absolutely. Any others? There's others. There's C and D. Yes, C and D add up to 180. And G and H. Any others? Get creative with the way we're moving this thing. Which ones?
D and F.
D and F. Actually, yes.
And then C and E.
D and F can. C and E can. Now, we'll have to do a little bit more manipulating to see why that works, but you are correct. I can't show that with my straight line, but you are correct. What else? F and H? Yep. What else?
G.
E and G? Yes. What else?
A and C.
A and C? What else?
B and D.
B and D. Crazy. We just drew 3 lines, and there's all of those relationships that we can think of in there. That is really, really cool. Now, something that we can write, we don't have to put it on our notes necessarily. I don't want to make this page too crazy. So I'm going to do it on a sticky note. And if you would like to use a sticky note as well, there should be at your table sticky notes. I'm going to write that I know angle A is equal to angle D is equal to angle E is equal to angle H. I just wrote down all my yellow angles. They're all equal to each other. I could also write B is equal to C is equal to F is equal to G. we just pointed out a bunch of the angles that add up to 180. So I'm going to have us look back at A and B. What equation could I write with A, B, and 180? It's okay if we don't know the measure of either one, but could we write an equation? What would that be? Yes.
A plus B equals 180.
Yes, A plus B equals 180. So angle A plus angle B equals 180. Because they are supplementary, they make a straight line. Up here, we just said that angle A is the same as angle D. It's also the same as E. It's also the same as H. Would it be reasonable for me to say, since these angles are all the same, A, D, E, and H, could I replace A in my equation with any of those four angles up top?
Yeah.
I could. They're the same. It's just like replacing variables. I could say angle D plus angle B equals 180. Is that true? Is this true?
Yeah.
It sure is. I can check on my picture. There it is. D and B do equal 180. But even if I didn't have a picture, I just told you up here that A is equal to D. And if A plus B is 180 and A is equal to D, then D plus B is 180 because they're the same. I want to talk about the angles also that Jessica pointed out. You pointed out that D plus F make 180, or C plus E makes 180. So let's write angle D plus angle F equals 180. I know that I can replace A with D because we just did that above. A and D are equal. Can I say that D plus F is 180? I'm going to look at these relationships here. I have B as my second term in this equation. B is equal to C, B is equal to F, B is equal to G. As long as that second one is B, C, F, or G, it's going to be true because they're the same, right? So this last equation is true. You can do all kinds of stuff with this. It makes a little more sense in context. I know we're kind of just talking about it for now, but I think it's neat. I think it's cool to see how many things you can move around and change. Okay. Do you have any questions about anything we just wrote? We wrote a lot. So it is 1:54. It's almost 2 o'clock. I am thinking this is a great time for us to take a break. You guys have done a really nice job so far today. We've gotten some good notes down. We are going to come back at 2:10. That gives you 15 minutes to stretch your legs, bathroom, drink, whatever you need. And then at 2:10, we will use these notes to do some practice together and kind of expand on this. So I'm going to pause our recording and feel free to take a break. And we'll be right back. All right, so we are back from our break. And we've just taken these notes. I'm going to put those to the side for just a moment. And I would love for all of you to look at this worksheet I gave you. And it is titled Parallel Lines and Angle Relationships. And based off of the notes that we just took, We're going to do a couple of practice problems together. So looking at number 1, we're going to start off here. And the very first thing I will always recommend is before you even try to set up an equation to solve for x like it's asking us, we want to ask ourselves one of two things. There's two options. Are these angles equal to each other, or do these angles add up to 180? So I'm going to write those options because those are always our two options when we have parallel lines with a third line going through them. Two options. The angles equal to each other, or do the angles add up to 180 degrees? So thinking about these two options, let's look at number 1. We don't even need to worry about the measures. We just need to look at where the angles are on the picture. What are we thinking for these two angles? Do they seem equal to each other, or do you think we will add them up to 180 degrees? Equal to. These angles are equal to each other. Why? How do we know they're equal instead of adding up? That's a harder question to answer.
I just like to think of it as like it's weird.
It's mirrored.
Yeah.
Oh, that's such a good way to think of it. This is a mirrored angle. The name of this relationship, and we can write that on this paper here, or we can make a note of it. First, I'm going to actually mark both angles with an arc. The same arc, because they're the same angle. These angles that are right across from each other, they're made up of the same two lines. They are called vertical angles. And vertical angles are always equal to each other. Angles right across from each other are vertical angles, and they're equal. So if I were to say that the 100-degree angle is A and the other one is B, I know that A is equal to B. What equation could I write using the values given to me? What are we thinking?
You do 100?
Yes, A is 100.
So equal to 10.
Good. Equals B, which is 10x plus 10. So all we did is we just replaced A with 100 and B with 10x plus 10. We don't even have to do the A and B part. That's an extra step. We could just say, I know these are equal, so I'm going to write that, which is 100. I'm going to say it's equal to this, which is 10x plus 10. So now I have an equation. What should I do from here? Minus 10 on both sides. And again, if it helps to draw a line, keep yourself organized, do it. Not a bad idea. So we'll do minus 10 over here and minus 10 where else? Under the 100. Good. Okay, those 10s will cancel out, and I'll bring everything down. 10x comes down. Now, what's 100 minus 10? 90. And we're still trying to solve for x. We've got one more step to go. Divide by 90. So if I divide by 90, what happens is I'll have 90 divided by 90 is 1. 10x divided by 90, which is going to give me a decimal, and it'll still be in front of x.
So it would be 9.
It would be 9. You have the correct answer. But I want to make sure we know how to get there by writing it out. What exactly are you doing to get 9 as your answer? Divide by 10. Yeah. So we're trying to get rid of the things that are with x because I want x to be all by itself. So the only thing that is here with x is the 10. This is 10 times x, or x times 10. To get rid of multiplication, we divide. So divide by 10, divide by 10. So you knew how to do it.
That's what I meant. I think I said it wrong.
Oh, you're okay. You're okay.
I said 90 divided by 10. I meant 6 divided by 10.
You're okay. You're okay. Okay, so 10 divided by 10, that's 1. So we have x by itself equals, what's 90 divided by 10? 9. So, number 1, x is 9. Even though we have 9 on the right side instead of the left, x equals 9 is the other way that you could write this. It does not matter which side you put it on. Could I also solve this by writing my equation instead of with 100 first? Could I do 10x plus 10 equals 100?
Yes.
Yes, you could. In fact, I think that way is probably going to feel easier to most of you because I think we're used to, we're more familiar with x coming first. So it's never a bad idea. Go ahead and make sure your x is on the other side. But you can do it this way as well. Both ways work. Okay, let's look at number 2. First, let's decide, are these angles equal or do they add up to 180? Number 2. What do you think, Kelsey?
I think they add up.
You think they add up to 180? Okay, so what makes you think they add up to 180?
Mirrored, and if you, or wait, no, hang on.
Oh. Oh. Oh.
Got me.
Okay, what are we
Okay.
thinking now? Equal or 180? This is another great way to check. You can always pull out this little sheet and trace your angle when in doubt. Let's see. 110. I'm going to trace that. Now let's overlap it. Let's move it around and put it over the top of this angle, 37x minus 1. Is that the same or is it different? It's the same. It equals. These two angles are going to be equal to each other, right? If you also don't feel like using this little clear piece of paper, another thing you can do is look back at your notes and think about how these are laid out. If I start with one angle, start with 110, and I can think to myself, well, what's equal to 110? I know the angle right across from it is equal, just like in my picture, A and D. So this is equal to that. And if I look at my picture again, I see the one that is in the same position. I've got 4 angles here, 4 angles here. This one is equal to this one and this one. You see what I just did? I'm just copying the yellow angles onto this paper. So
I think I just got the terms.
that's okay. You're fine. You're fine. No big deal.
That's exactly what I meant.
Good, good. So 110 is actually equal to 37x minus 1. Is anybody still unsure why they're equal instead of adding up to 180? Or do we feel good about that? You feel okay? Okay. All right. So now I know they're equal. What equation could I write? Yes, I can say 110 equals 37x minus 1. Now, if you like to have your x first, which I actually do prefer x coming first, you can also say 37x minus 1 equals 110. So I'm going to write it that way this time. 37x minus 1 equals 110. And is that yellow? Can you see this still? Is it hard to see?
You can see it on there.
Okay. Just don't want anybody to be struggling to see the numbers. I'll trace over it just in case. I don't know how it'll show on YouTube. So here's my equation. They are equal. What would I do to solve this? Plus 1. Let's get rid of 1. Good. Plus 1 on both sides. And where do I go from here?
37x equals 101.
Good. 37x equals 110 plus 1 is 111. And I've got one last step.
537.
Yes. Divide by 37 on both sides. That's going to get rid of those. And I have x by itself equals. My calculator went. Somebody tell me the answer.
53.
Should be 3. That sounds right. 111 divided by 5. Yep, 3. Perfect. X equals 3. Beautiful. All right, so that's number 2. So the first 2 problems we've done have both been equal to each other. That's not always going to be the case, so I want to make sure we go through examples of other types. I'll leave this up for a moment before we move on, but let's look at number 3 next. And does anyone still need to see this, or can I move it? Anybody? Okay, I'm going to scoot on down to number 3. Let's look at this one. Now I have 2 angles right next to each other on the inside. 20x plus 1 and 79. Are these angles equal to each other, or will they add up to 180? Add up to 180. How did you know they would add up to 180? They're not the same size. They're not the same angle. They aren't across from each other. They're not in those 4 equal positions. They're right next to each other. Usually, if they're across, they're equal. If they're beside, they add up to 180. Now, we can double check this in a couple of different ways. First, we could compare it to our notes, and I could see 2 angles on the same side inside of these lines, C and E. They add up to 180 because they're different. We could also trace over the angles and see that 79 is smaller, 20x plus 1 is bigger. There's a few ways we could figure that out. So I'll make a note here. These will add to 180. So I'm going to mark these with a different number of arcs. 1 arc for 20x plus 1, and I'll do 2 arcs for 79. So what equation could I write here?
20x plus 31.
Yes, 20x plus 1 plus 79 equals 180. We're just adding them together, equal 180. So I have my equation. What's a good next step?
79 plus 1.
Yeah, let's add 79 plus 1. We have like terms. So let's combine those. And what does that give us?
80.
80. So I'll bring everything down. 20x plus 80 equals 180. And let me pause this. Okay, what's next?
Minus 80 on one side.
Yes, minus 80 on both sides. And then what?
28 equals 100.
Perfect. 20x equals 100. And I'm running out of space. I'm going to rewrite that up here. 20x equals 100. One step left. What is my final step here? Divide, what'd you say? 2? I could divide by 2.
20.
20. Yes, you're okay. Divide by 20. Good. That gets rid of the 20 on our x, so it is by itself equals, what is 100 divided by 20?
5.
5. X equals 5. Wonderful job. Wonderful job. That is number 3. Okay. We feel like we're starting to get the hang of it? Good. Good. Okay, now before I let you guys try a couple on your own, I do want to show you how sometimes these can get just a little bit trickier. Because in the first few problems, one angle has no variable on it. We have just a number, 79, and then the other angle has an x. Your last 2 problems we had this angle was 100, there was no x. This one was 110, no x. But what if we have something like number 4? Or even, let's do one that might even be trickier than that. How about we look at number 6? And I'll leave the others for you guys to go back to. I want to look at number 6 for a second. First of all, are these equal or do they add up to 180 degrees? Add up to 180. Beautiful. Okay, so I know that they're going to add up to 180. So the only thing that's different is now we have more things to add together because it's not just a number by itself. There's variables involved in both angles. So what equation would I write for number 6? Does anyone know?
X minus 2
Okay.
plus 32x
Mm-hmm.
plus 2.
Yes, yes. 13x minus 2 is my first angle. I'm going to add that to my second angle. All we're going to do is just write all those values. So 13x minus 2 plus 32x plus 2. And we're going to set all of that equal to 180. We're adding them to equal 180. So the only thing that gets a little trickier here is we have more like terms to combine. or more things to move over to the other side, depending on how you like to solve your equations. I'm going to have us practice combining like terms because I think that's just the method that we've been doing. So our equation is written. Let's start with our x's. Do we have like terms that are x's that should be combined? Yes, 13x and 32x. We need to combine these. And what is 13 plus 32? 45. So now I have 45x. And I could bring down my minus 2 plus 2, or I could combine everything at once. What other like terms are there?
Energies cancel.
Oh my goodness, they do. They cancel. Oh my gosh, let's talk about that. Minus 2 and plus 2 are like terms. Neither of them have x's, they're just numbers. So minus 2, or we could think of this as negative 2, plus 2, if I type that in, negative 2 plus 2, that's 0. I could write 45x plus 0. I'll do that. Let's see what happens. That's 0 when I put those together. But when I'm trying to get x by itself and I bring everything down, equals 180. When I'm trying to get rid of 0, I guess I could subtract 0 from both sides. Does that really change anything in my equation? No. So when you have numbers that add up to 0, you really don't have to write them. You could just cross them off and say they cancel out. Now that's only true if they're on the same side of the equation, that same side of the equal sign, and if those signs are opposite. We have plus 2 and minus 2. Same number, different sign. So really I have 45x equals 180. Okay. Where would I go from here to solve for x? Yes, divide by 45. And I get x equals 4. Perfect. And then you're done. X equals 4. Very nice. Okay, guys, so we've run through 4 of those together. We did number 1, number 2, number 3, and number 6. So what I would like to do now is I'm going to set a timer for about 10-15 minutes. I would like for you guys to go through the rest of the problems we have not done and try to solve for x on as many of them as you can until the timer runs out. You guys are welcome to help each other out. If you have questions for me or get stuck, I've got chairs up here at my desk. Feel free to come up to me and ask me about any of it. But when that timer goes off, I'm going to open the floor up and let you guys tell me about any of them that gave you trouble, any of them that you feel confident about and just want to share your answer. And we'll make sure that we all feel good about it before we get an exit ticket. So I'll pause our recording, put a little background music on, and I'd love for you guys to work on that until the timer goes off. Okay, so I just gave you some time to work on these on your own. And I would like to open the floor to you all and tell me, are there any numbers on the front or the back that you felt were like a little bit tricky and maybe we want to go over together? Yes. Number, you said, which one? Number 5? Okay, yes, number 5. Let's look at number 5. Okay. So, number 5. What is the first thing we need to think about with these angles before we set up an equation? What are our options? Yes, are they equal to each other or do they add up to 180? What do you guys think? I think they're equal to each other. Yes, yes, they're equal. These angles are equal. Another name for the angles that are in the same position, meaning like we have 4 angles right here in this circle. When I move down, this is in the same top right hand spot of those 4 angles. These are called corresponding angles. So I'm just going to write that just as an FYI. Corresponding angles, and they are equal to each other. So what equation could I write knowing that these two values are equal to each other?
8x plus 13 equals 9x plus 5.
Perfect. 8x plus 13 is equal to 9x plus 5. Okay, now this one is a little tricky because we have x's on both sides of the equal sign. So whenever we combined like terms in, for example, number 6, our x's were luckily on the same side of the equal sign, so we could just add them together. Something different will have to happen here because they're not on the same side of the equal sign. So what are we thinking? What could we do here? Add like terms. Do we have any like terms on the same side? Like, let's look at just 8x plus 13. Can I combine anything over there? No. Can I combine anything over here? No. We do need to get our like terms together, but we can't just add them. Yeah, we need to try to get them on the other side of the equal sign. So this is where we use inverse operations. We got to do the opposite thing to combine. So Riley said, let's subtract 5. Yeah, let's do that. I'm going to subtract 5 to get rid of this 5. And if I do it to one side, where else do I subtract 5 on the other side? Under 13. Under 13. Good. 5s will cancel. Now, what's 13 minus 5? 8. Okay, so I have 8 here. I will bring down equals. I will bring down 9x. I will bring down, I still have 8x over here. 8x plus 8 equals 9x. Now this looks tricky. This is where we might get a little mixed up. How on earth am I going to get my x's on the same side? What can I do? Yes. Okay, so instead of adding them, because they're not already together, to get them together, we have to cancel the 8x over here. To make that cancel, we're going to subtract 8x. So let's do that. Minus 8x. And luckily, I have an x on the other side, so I can subtract 8x from 9x. Does that make sense, what we just did? Everybody okay with that? Okay. So I got rid of my x over here. Now what comes down?
Just x.
Ah, yeah. 9 minus 8 is 1. 1x. I can just write x. Bring down my equals. What else comes down? 8. Oh my gosh, we're done. That's it. That's it. Now, it's a little funky because our x is on the side that we're not used to it being on. That's okay. 8 equals x is the same thing as x equals 8. You can just flip the side that it's on. That still works. That still works. Can we do it again? Oh, number 10. Yes, yes. Before we go to number 10, any questions about 5? Did anything not make sense, or are we okay?
I don't think we still took the 8x over to the, on the other side.
Yes. We took the 8x to the other side.
It makes sense, but it doesn't make sense, because we was not doing that at the start of the.
Right, right. So what's difficult about this one is it's one of those where we get an equation with variables on both sides. So let me show another little example similar to this where we have to do something like that. And then we will do number 10 next. So let's say I have 12x plus 4 equals 11x plus 3. This is an example. I'm going to draw a line where my equal sign is so that I keep things in line. Something that I think makes this whole process a little bit easier and less confusing is if we just right away, we mess with the x's first. I think sometimes if we do like we did here, we subtracted 5 first. Yes, that is a correct way to do it. It worked. We got our answer. But sometimes whenever we have just x's that need to be combined left and there's nothing else, I don't know, it just throws us off. So how about we do the x's first? I have 12x on one side. I have 11x on the other side. So I have 2 options. What is one of the options? What could I do? I could subtract 11x from both sides. I could also do what?
Same thing we did on the other one.
I could do the same thing, but with the other one, with 12x. I could subtract 12x from both sides. Now, if I subtract 12x, 11 minus 12.
That would give you a minus.
Yeah, that's -1. You can do that, but you're going to have to
Do more.
you're going to have to do more. So if you do your x's first, you can avoid that uncomfortable situation and just say, okay, which one is going to give me the positive x? So I'm going to subtract a smaller number. Let's subtract 11x minus 11x. And then what happens at this step? What happens with 11x over here? It cancels. Okay, I'll bring down my 3. I'll bring down my equals. I'll bring down plus 4. And then, yeah, 12x minus 11x is just x. Now what should I do?
Subtract 4.
Subtract 4. And those cancel, and I'll get x equals -1. Nice, good. So with this problem, we did the same exact thing. We just reversed our steps. We could have started by doing -8x on both sides, which would give us x over here. That might make more sense to a lot of you. Let me write that out real quick, and then we will get to number 10. So if I had, it was 8x plus 13 equals 9x plus 5. I'm always going to recommend combine your x's first. Subtract the 8x. Subtract the 8x. Those 8x's cancel. And then I'm left with 13 equals 9 minus, or 9x minus 8x is just x plus 5. From here, does this look a little bit easier to solve? Yes, I think so too. All we have to do is subtract 5. And guess what? We'll get the same answer. X equals 8. Which is what we got here. 8 equals x. X equals 8. Same thing. Perfect. Does that help a little bit?
Awesome.
Yay. Okay. Awesome. Okay. I'll leave it up for just a second. I see some of us are writing. And then we will look at number 10. And a few more seconds here. Can I move this? All right. Okay. Flipping to the back. We're going to look at number 10. My options are the angles are either going to be equal to each other or we'll add them together and they'll equal 180. Which one are we thinking? Equal or 180? Which one? 180. They are right next to each other on the inside. These will add up to 180 degrees. So, what equation could I write?
That equals 110
Mm-hmm.
plus. Yeah, plus 90.
Perfect. Equals 180. Beautiful. So this is the equation we'll write. We just did x plus 10 or 110 plus the other value, x plus 90, and those add up to be equal to 180. So our equation is written. What do I do from here?
Right, 9.
Subtract 90? We could definitely do that. Okay. What happens now? Bring everything down. X plus 110 plus x. 90s are canceled. Equals 180 minus 90 is 90. Okay. What could we do next? What do you think?
So you're gonna combine your x's.
Let's do it. Let's combine our x's. How do I do that? Am I just adding them together? Am I gonna have to subtract anything?
Are you gonna use an exponent?
I don't think so. No exponent. We would if we had to multiply them, but we're just adding, luckily. What? So somebody was talking to.
Was it 2x?
2x. All we have here is x plus x. Remember, this is like 1x plus 1x. That's 2x. Okay, and then what do I do?
Equals 90?
Equals 90. What am I missing? Plus 110.
Oh.
Oh, we almost forgot it. Plus 110 equals 90. Now what? Yes, subtract 110. Those will cancel. Bring down 2x equals, you will get a negative number. That is allowed. That is okay. Because we're not finding the measure of the angle. We're just finding x. X can be negative. What comes down here? 90 minus 110 is negative 20. Is that right?
Yes.
Okay. Negative 20.
That's what confused me. I didn't know we could do the negative or not.
Yes.
I had it written out different than this, but I still got the same answer.
Perfect. Yes, there's so many ways to get the same answer. This is different than we've been doing
Yeah,
it.
I thought it was wrong, so I did the O.
Nope, you're doing it right. What's my last step? Divide by 2. X equals, should get negative 10. There you go. Okay, now, the way that we would normally do this, that would be even shorter. I'm going to write it out kind of right next to it. Normally, I will always recommend.
I think that's the way I did it, the way you're about to.
Oh, yeah. Did you combine like terms?
Yeah.
Yes. That way we'll usually be a little quicker.
90.
Yeah. Okay, so in this step, you said you did 110 plus 90 because those are like terms.
I did like to say.
Yes, and like terms with the x's. So instead of doing a bunch of steps, we can do it all at once. X plus x is 2x. 110 plus 90, what's that? 200 equals 180. What'd you do next?
Minus 200.
Yep, minus 200. And you got 2x equals negative 20. Good. And look, now it looks just like this problem. Divide by 2. And we get the same answer. X equals negative 10. Good. So your work may not look the same as your neighbor's work, as your classmates' work. There are so many different ways to solve these problems. As long as you're following the math rules, you can do it in a lot of different ways. Both of these ways are correct. Whatever makes the most sense to you, you can do that. Do we have any other questions? Number 4. Let me look at that real quick. Number 4. Okay. Let's do number 4 real quick. And then I can go back and show you number 10 if anybody didn't finish writing. So number 4, are these equal to each other or do they add up to 180? Add up to 180. Good. There's a big angle and a little angle. They're very clearly not the same size. So they can't be equal. They add to 180. So what equation could I write? What are we thinking? Perfect. 4x plus 10 plus 13x equals 180. What did you do next? Yeah, that would make it a little trickier.
Subtracted 4x.
Subtracted 4x. Okay, so if you subtracted 4x, did you also subtract 4x somewhere else? That's okay. Okay, so let's talk about this. Whenever we have like number 5, we ended up needing to subtract our x's to combine them because they were on different sides of the equal sign. But when you have x's on the same side of the equal sign, we don't have to do anything opposite. We're just going to combine them, right? Combine like terms. I have 4x and I have 13x. We can just add them together. So what is 4 plus 13? 17, is that right? Okay, so 17x, bring down plus 10 equals 180. Ah, they can be tricky. Okay, I've combined my like terms. I brought everything down. Go ahead, Nita. Minus 10 on both sides. Good. Okay, so that canceled my 10s. I'll bring everything down. 17x equals what? 170. 170. And there's one more step.
Divide.
Yes, divide by 17. Okay, x equals 10.
Okay, what I did instead, plus 9. I subtracted 10. I got rid of 10 first.
Okay, subtracted 10 first. Great, that's one of the
Right.
steps we took.
But what I got confused with was just the these buttons. For some reason, my brain thought they were opposite sides.
I get you. That is completely okay. It happens. It happens to the best of us.
I did it.
Oh, poor thing. I'm sorry. It makes sense now, though. Perfect.
Now I understand.
Perfect. Okay, guys. I'm happy to show any of these problems again if anybody needs to see them. But for now, I'm going to give you your exit ticket for today. And that exit ticket I will make copies of, but if you don't want to wait for the copies, you're welcome to write it yourself. If you do write it yourself, please label your paper with day 2 exit ticket. I will make copies of this. And this is geometry. Give you a spot to write your name. And this exit ticket is due Friday, this Friday. That's October 10th at 12 p.m. Okay. And for your exit ticket, I want you to solve for x. And I am going to use a problem from this worksheet that I didn't give you the answer to. Let's look at let's do number 7. So I'm going to draw it. Just going to give myself parallel lines. A trick for parallel lines, if you just don't move your ruler, you can draw them both at the same time. Just like that. And then I'll make it look kind of like the picture on the paper. Okay, and the first value here is 4 plus 19x. And the second value is 26x minus 4. So I've got that problem written out for you. Only thing I need to do still is mark that these are parallel because that makes a difference. Okay, and I will freeze my screen for anybody that needs to still see this problem. And I'm going to run some copies really quickly for all of you. But other than that, that is it for today. So if you finish this before I get back, you are free to go. Make sure you turn it in under the board right there. But I'll be back with copies and bring them to you if you want to wait for that. Up to you. Other than that, the end.